12,900 years ago, North America was a different world. Mammoths grazed the Great Plains. Mastodons moved through forests that no longer exist. Giant sloths the size of elephants wandered the landscape. Horses, yes, horses were native to North America, ran in herds across open grasslands. Camels, short-faced bears, saber-toothed cats, and people. The first people to reach the Americas, the Clovis culture, had been living there for at least a few hundred years. Skilled hunters, highly mobile, extraordinarily adaptable. They had crossed into a continent that no human being had ever touched before, and they had thrived. Then, in what geologists estimate was the span of decades, possibly a single generation, everything changed. The megafauna began to disappear, not gradually. Within a few thousand years, 35 genera of large mammals were gone. The mammoth, the mastodon, the horse, the camel, the giant sloth. Species that had survived multiple ice ages, multiple climate shifts, multiple changes in the landscape, gone. The climate lurched into what we now call the Younger Dryas, a sudden, severe cooling event that lasted 1,200 years. Temperatures in the North Atlantic region dropped by 10 to 15 degrees Celsius, twice the temperature difference between a full ice age and a warm interglacial period, in decades. And across North America, there is a layer in the geological record, a thin, dark layer, approximately 12,900 years old, containing materials that geologists don't usually find in sediment from this period. Materials that have made a small group of researchers argue for nearly 20 years that something fell from the sky. In our last video, we covered the Younger Dryas, the event itself, its effects on early human societies, and the mainstream explanation for what caused it. If you haven't seen that one, it's worth watching first. It sets the stage for everything we're about to go into. Today we go deeper into the most controversial hypothesis in quaternary science, into the evidence that has divided researchers for 2 decades, into the question that, if the answer is yes, would rewrite our understanding of what happened to North America 12,900 years ago. Did something fall from the sky? Let's find out what the evidence actually shows. To understand what was lost, you need to understand who was there. The Clovis culture is named after a small town in New Mexico, where, in the 1930s, archaeologists found something unexpected: fluted stone spear points buried alongside the bones of extinct mammoths. The implication was immediate and extraordinary. These were not just ancient tools, they were hunting weapons, used by people who had lived alongside animals that no longer existed. Clovis points, as the distinctive fluted projectile points came to be called, have since been found across virtually the entire North American continent, from the Atlantic coast to the Pacific, from Canada to Central America. Wherever large game animals once roamed, Clovis hunters followed. The current consensus places the Clovis culture at roughly 13,000 to 12,600 years ago. They were, as far as we know, among the first humans to populate the Americas, though the debate about pre-Clovis populations is ongoing and genuine. There is credible evidence for human presence in the Americas before Clovis, but Clovis is the first widespread, well-documented culture. The Clovis people were not struggling survivors at the edge of habitation. The evidence suggests they were extraordinarily successful. They moved quickly across landscapes. Clovis sites span an enormous geographic range, and the archaeological evidence suggests a culture capable of rapid dispersal, following herds, exploiting seasonal resources, moving with the rhythms of a continent full of large animals. Their tools were sophisticated. The Clovis point itself is a technical achievement, a biface fluted at the base to fit into a hafted handle, requiring precision knapping of stone that took years to master. These were not people improvising survival. They were skilled craftspeople who had refined their technology over generations. And they lived alongside giants. The Columbian mammoth, larger than its woolly cousin, roamed the warmer regions of North America. The mastodon occupied the forests. The glyptodon, an armadillo the size of a small car, lumbered through the south. The American lion, larger than any living lion today, was the apex predator of the continent. This was the world of the Clovis people, rich, abundant, unlike anything that exists today. North America at 13,000 years ago was emerging from the last ice age. The great Laurentide ice sheet that had covered Canada was retreating. Sea levels were rising as meltwater poured into the oceans. The climate was warming, not smoothly, but in the general direction of the Holocene conditions we live in today. The landscape would have looked recognizable in some ways, alien in others. The Great Plains existed, but they were different, richer, more varied, teeming with species that have no modern equivalents. The Mississippi Valley was a major corridor for both animals and people. The coasts were different. Lower sea levels meant more land, different coastlines, different bays and estuaries. And then, in what may have been a single night or a single season, everything changed. In the geological record, there is a boundary. Archaeologists and geologists call it the Younger Dryas boundary, or YDB. It marks the transition from the warm Alarode period to the sudden cold of the Younger Dryas, approximately 12,900 years ago. At sites across North America, and at dozens of sites in Europe and the Middle East, this boundary layer contains something unusual. Above it, cold-adapted species, a changed landscape, the beginning of the Younger Dryas world. Below it, mammoths, Clovis artifacts, the rich late Pleistocene world. At the boundary itself, a concentration of materials that require explanation. One of the most striking features of the YDB layer is the evidence of widespread burning. Charcoal, soot, and combustion products appear in sediment records from multiple sites across North America at approximately the same time. This in itself is not unusual. Wildfires have always burned across the continent. What is unusual is the scale and simultaneity of the burning suggested by the record. Multiple locations across a vast geographic range showing evidence of intense burning at the same stratigraphic horizon. Some researchers have interpreted this as evidence of impact-triggered wildfires, fires ignited not by lightning or human activity, but by the thermal pulse of a cosmic impact or airburst, or by burning debris raining down from the sky. Others argue that the evidence can be explained by naturally occurring wildfires, climate change drying the landscape, more lightning strikes, accumulated fuel loads. The fires are real. The cause is contested. The extinction of the North American megafauna is one of the great mysteries of the Quaternary. 35 genera of large mammals disappear from the fossil record in North America within a few thousand years of the Younger Dryas. This is not a gradual, steady decline. It is a collapse. Two explanations have dominated the debate for decades. The first, overkill. As Clovis hunters spread across the continent, they encountered animals with no experience of human predators. Animals that did not run from people. That could be approached closely and killed with relative ease. Systematic hunting drove the megafauna to extinction within a few hundred years. The second, climate change. The rapid onset of the Younger Dryas transformed the landscapes these animals depended on. The rich, diverse habitats of the late Pleistocene gave way to harsher, more monotonous environments. Animals adapted to the old world could not survive in the new one. The impact hypothesis adds a third possibility. The extinctions were triggered by the impact event itself, by the immediate destruction, the wildfires, the climate disruption, and the ecosystem collapse that followed from a cosmic impact at the Younger Dryas boundary. The honest answer: the debate is not settled. Most researchers today favor a combination of human hunting and climate change. The impact hypothesis remains a minority view, but it has not been dismissed. The Younger Dryas cooling, the sudden return to near glacial conditions after thousands of years of warming, is the backdrop against which all of this happened. In our previous video, we covered the mainstream explanation. A massive pulse of fresh water from glacial Lake Agassiz disrupted the Atlantic meridional overturning circulation, cutting off heat delivery to the North Atlantic and triggering the cooling. The impact hypothesis doesn't replace this explanation. It potentially precedes it. The argument is that a cosmic impact could have triggered the freshwater pulse, destabilized the ice sheet, and set off the chain of events that disrupted ocean circulation. Or the impact could have contributed to cooling through other mechanisms, injecting dust and debris into the atmosphere, reducing solar radiation, triggering fires that further disrupted the climate. The mechanisms are speculative. The cooling is real. The question is what started it. If you've made it this far, you probably want to know how this story ends. Subscribe so you don't miss the next investigation. And if you watched our Younger Dryas video, you already know we don't stop at the comfortable answer. In 2007, a team of 26 researchers published a paper in the Proceedings of the National Academy of Sciences. Their claim: a cosmic impact, most likely a fragmented comet or asteroid, struck or exploded over multiple locations in the Northern Hemisphere, approximately 12,900 years ago, triggering the Younger Dryas, the megafaunal extinctions, and the collapse of the Clovis culture. The paper made international news. It was bold, specific, and supported by a wide range of co-authors from multiple institutions. And it immediately attracted intense scrutiny. The evidence presented by the impact hypothesis proponents focuses on materials found in the YDB layer at sites across North America, Europe, and the Middle East. Nano-diamonds. Microscopic crystals found in concentrations at the YDB layer that the researchers argued were consistent with impact shock, high pressures and temperatures that can only be produced by cosmic impacts or nuclear explosions. Not found in the sediment layers above or below, only at the boundary. Platinum. The YDB layer shows elevated concentrations of platinum at multiple sites. Platinum is rare in Earth's crust, but relatively common in asteroids and comets. A spike in platinum at a specific geological horizon is one of the key signatures used to identify impact events. It was the platinum and iridium spike that confirmed the asteroid impact that killed the dinosaurs. Magnetic spherules. Tiny iron-rich spheres found in abundance at the YDB layer. These can form when molten rock or metal is ejected into the atmosphere and solidifies in flight. They have been found at known impact sites. They appear in elevated concentrations at the YDB boundary. Melt glass. High silica glass found at some YDB sites, showing temperature signatures consistent with formation at extremely high temperatures, hotter than any known volcanic process, consistent with impact melt. And the Hiawatha crater. In 2018, a separate research team announced the discovery of a large impact structure beneath the Hiawatha Glacier in northwest Greenland, 31 kilometers wide, potentially formed as recently as 13,000 years ago. The dating is uncertain, and the crater may be older, but its existence proves that a significant cosmic impact occurred in the Northern Hemisphere in broadly the right time frame. One of the more striking aspects of the impact hypothesis evidence is its geographic distribution. The YDB layer with its anomalous materials has been found, or claimed to have been found, at sites across North America, in the UK, in continental Europe, in the Middle East, and in South America. If this is real, it suggests not a single impact point, but a dispersed event, a fragmented body that broke apart and struck or exploded over a wide area. Like the Shoemaker-Levy 9 comet, which fragmented and struck Jupiter in 21 separate pieces in 1994. A fragmented comet airburst, traveling at cosmic velocity, exploding across the northern hemisphere, could theoretically produce exactly the kind of wide geographic distribution that the impact hypothesis evidence shows. Theoretically. The impact hypothesis has been vigorously challenged, and the objections are serious. Replication failures. Multiple independent laboratories have attempted to reproduce the findings of the impact hypothesis papers to find the same nano-diamonds, platinum spikes, and magnetic spherules in the same sediment layer, and have had inconsistent results. Some studies confirm the findings, others find nothing. In science, a hypothesis that cannot be reliably reproduced by independent researchers is a hypothesis under serious pressure. The nano-diamond controversy. The specific type of nano-diamonds cited by impact proponents, lonsdaleite, a hexagonal form of diamond associated with shock metamorphism, has been disputed by other researchers who argue the structures identified are misidentified graphene. This is a technical dispute about electron microscopy, but it matters. If the nano-diamonds are not what the proponents claim, a key piece of evidence collapses. The charcoal problem. The widespread burning evidence at the YDB layer can be explained without an impact. Climate change during this period, drying conditions, increased lightning activity, accumulated fuel loads from decades of plant growth, provides a plausible natural explanation for elevated burning at the same general time horizon. The Hiawatha uncertainty. The crater beneath the Hiawatha Glacier is real, but its age is uncertain. The most recent dating work suggests it may be 58 million years old, far too old to be the Younger Dryas impact. Other analyses suggest it could be younger. The crater is real. Whether it is the Younger Dryas crater is genuinely unknown. Despite the objections, the impact hypothesis has not been ruled out, and the reason is that some of the evidence is genuinely difficult to explain any other way. The platinum spike is real and has been confirmed by multiple independent labs at multiple sites. Platinum this elevated in a geological horizon of this age requires an explanation. The most parsimonious explanation remains a cosmic source. The geographic distribution of the YDB markers, if the evidence holds up under continued scrutiny, is difficult to explain by any terrestrial process. Wildfires don't leave platinum spikes. Ocean circulation changes don't produce magnetic spherules. Something deposited these materials across a wide geographic area at the same time. The timing remains striking. Whatever caused the Younger Dryas, it happened fast. The AMOC disruption hypothesis is compelling, but has its own evidentiary problems. The direct evidence for a freshwater flood of exactly the right magnitude, in exactly the right location, at exactly the right time, is harder to find than the hypothesis requires. The impact hypothesis provides an alternative trigger mechanism that doesn't require those specific conditions. The Younger Dryas impact hypothesis is not the consensus explanation. The mainstream scientific view remains that ocean circulation disruption, triggered by a freshwater pulse from glacial lake Agassiz, caused the Younger Dryas cooling. But the impact hypothesis has not been falsified. The debate continues in peer-reviewed journals. New evidence is published regularly, some supporting the hypothesis, some challenging it. The Hiawatha crater needs better dating. The nano-diamond controversy needs resolution. The platinum spikes need continued independent verification. This is what a genuine scientific controversy looks like. Not one side clearly right and the other clearly wrong. Not suppressed knowledge. Not conspiracy. A real empirical dispute conducted in the open, with evidence on both sides and no clean resolution yet. That's not a failure of science. That's science working. What exactly is in the Hiawatha crater, and when was it formed? Better dating of this structure could either confirm or effectively rule out its connection to the Younger Dryas. Can the nano-diamond and platinum evidence be consistently replicated across independent laboratories? This is the core scientific question. If the markers are real and reproducible, the impact hypothesis becomes much harder to dismiss. If they cannot be reliably found, it becomes much harder to sustain. What happened to the Clovis people? The culture disappears from the archaeological record at approximately the same time as the Younger Dryas boundary. Did the impact, if there was one, destroy it directly? Did climate change make their way of life impossible? Did they survive and transform into the post-Clovis cultures that followed? The evidence is suggestive. The answer is not established. Underneath all of this is a question that goes beyond the Younger Dryas. How often does Earth get hit by significant cosmic objects? And when it does, what are the consequences? We know the KPG impact 66 million years ago killed the dinosaurs. We know the Tunguska event in 1908 flattened 2,000 square kilometers of Siberian forest with no crater. We know the Chelyabinsk meteor in 2013 shattered windows across a Russian city and injured 1,500 people. These are the events we know about. The Younger Dryas impact hypothesis asks whether there was a larger event more recently that we have only begun to find the evidence for. If the answer is yes, if something did fall from the sky 12,900 years ago and contributed to the collapse of North American megafauna, the disappearance of the Clovis culture, and the onset of the Younger Dryas, then we are living in a solar system more dangerous than the standard model suggests. The evidence doesn't tell us yet. 12,900 years ago, a world ended. Whether it ended because of what fell from the sky, or because of what flowed into the ocean, or because of what hunted across the plains, or because of all three at once, the result was the same. The mammoths were gone. The Clovis people were gone. The rich, strange, abundant world of the late Pleistocene North America was gone. What came after? The Holocene, the agricultural revolution, the rise of complex societies, everything we call civilization came after. Maybe the catastrophe made it possible. Maybe the stress of the Younger Dryas forced the surviving human populations to innovate, to adapt, to develop the technologies and social structures that eventually became agriculture and cities. Or maybe it just ended one world and another began. I think about this from Istanbul, a city that sits between two continents, built on a peninsula that was itself shaped by the same post-Ice Age world. The Younger Dryas ended. The seas rose. The Bosphorus formed. Everything I look at from my window is a consequence of what happened 12,900 years ago. The research is still ongoing. The debates are still unresolved. The questions are still open. The investigation continues. If you want to know what the evidence shows next and where it ends, join the excavation. Tell me in the comments, which collapsed civilization should we examine next?